In Chapter 11, we're going to talk about relations. So let's jump right into that in section 11.1. So relations are just going to be sort of this general category for things like equals, not equals, less than or equal to, greater than. This one's sort of hard to identify in space, where that one just divides and this one does not divide. Right, but we're actually going to see a definition that doesn't going to look quite like that at first, and then we'll see why this is sort of the right definition we want. So our definition of a relation is that a relation on a set A is a subset R, so R is actually the relation, of A cross A. So a relation is just a subset of the Cartesian product on the set. So a relation is just a set of ordered pairs where each element comes from that set A. So then if the ordered pair X and Y is in R, then we say X relates to R, or X relates to Y, or XRY. And if XY is not in R, if it's not in my relation, then I'd say X is not related to Y. So let's see why this definition sort of corresponds with what we are used to thinking about in terms of the examples that we listed at the top. So again, I've just rewritten the example at the top of this slide here, and let's think about our less than relation. So what do I think about when I think about less than? I'm going to write down all of the things that I can say with that less than symbol that are true. So 1 is less than 2, 1 is less than 3, 1 is less than 4, right? But 1 is not less than itself, so that's a bad one. 2 is less than 3, 2 is less than 4, right? 2 is not less than 1, and 2 is not less than itself. And then 3 is less than 4, and 4 isn't less than anything. So now if I wanted to write this out in sort of a relation according to our definition, I would just write the set of all the ordered pairs that satisfy this. So I would say 1, 2, since 1 is less than 2, 1, 3, since 1 is less than 3, 1, 4, 2, 3, 2, 4, and 3, 4. So in particular, notice that I didn't have 1, 1. That's not in R. I didn't have 2, 1. That's not in R. Right? So in R, I'm just listing the things that satisfies this relation. So we can sort of see why we can think about these relations as ordered pairs. It's just the set of numbers that satisfy the thing that we're trying to say. Okay, so here's a question for you to try. So we have the set 1 through 6 here, and I want you to write out the relation that expresses this divides symbol. So think about which numbers divide which other numbers, and then write those out as a list of ordered pairs. Now when we're trying to visualize these relations, sometimes they can just kind of be arbitrary things. They don't necessarily have to come from something like less than or greater than. So sometimes we want to use a graph to help us picture these so we can kind of visualize what's going on. So if I want to use a graph to represent a relation here, I'm going to draw vertices. So I'm going to draw dots for each of my items. I skipped 2 there, so let me put that down here. 4 and 5. Doesn't really matter which order I put them in. Kind of makes me sad though that we have them out of order, so I'm going to switch it around. And now I'm going to draw a directed edge, so an edge with an arrow on it, for each of my ordered pairs. So 1 is related to 3, so I'm going to draw an arrow from 1 to 3. 2 is also related to 3, so I'll also go from 2 to 3. 3 is related to 5, so I'll draw that arrow from 3 to 5. 3 is related back to 1. Right, that was different than 1 being related to 3 because they have a different direction of that arrow. 0 is related to 2, so I'll draw an arrow from 0 to 2. And finally, 0 is related to itself, so I get this little edge that loops back around on itself. So that could be a graph that represents this relation here. Okay, finally here is a challenge problem. I want you to think about the set of integers and what it looks like to have the relation AB, where A is congruent to B mod 3. So you can think about this as listing out ordered pairs. You can think about this as a graph. Maybe you want to think about it just in some other way. So let's see if we can kind of visualize what this relation looks like, and we'll build up on that in class.